In recent years, the development of remarkably effective economic poisons, or pesticides, has increased man's advantage in his war on pests. Today, pesticides are used in more situations and for a wider variety of purposes than ever before. Production of the basic chemicals in the United States alone is over 500 million pounds per year. Every person is exposed one way or another. Modern pesticides are easy to use, highly effective, deadly poisonous to insects and rodents, but what about people? How do these high-powered poisons, so fatal to insects and such, affect people? The farm families whose homes are dusted right along with their crops, the operators of spraying and dusting equipment, and their co-workers. All these people undergo some degree of exposure to powerful poisons in the normal performance of their jobs. And so do the fruit thinners and harvesters, whose work takes them into poison-laden fields and orchards. And what about all of us, who must eat food that has been treated by poisonous sprays and dusts? Just what are pesticides doing to people? The Communicable Disease Center of the Public Health Service is seeking answers to this question at research laboratories in Wenatchee, Washington, Phoenix, Arizona, and Savannah, Georgia. The concern of these laboratories is to find out how poisonous these pesticides are, the way they act, and the types of injury they can cause, to learn the clinical symptoms and the course of illness from poisoning, to develop and test antidotes, and to determine what precautionary measures are needed for safe use of pesticides. Here, each new economic poison is subjected to exhaustive studies. Tests devised and carried out by trained research workers, utilizing an impressive array of unique tools and equipment. Laboratory animals also play an important role in many experimental studies. From controlled studies of animals comes valuable information on the immediate and long-range effects of pesticides, the relative safety or danger of different amounts of exposure, how much poison is stored up in the body and how much excreted, and the effects of pesticides on the vital organs. Experimental techniques and the kind of animal most suited for study may differ with each specific compound. But most pesticides in wide use today fall into one of two general groups according to the reaction they produce. DDT, the most widely used of all economic poisons, is representative of one of these groups. These poisons are slow in taking effect, but may remain active and potentially dangerous for many days or weeks. In this particular experiment, small, carefully measured doses of DDT are fed regularly to laboratory rats. The poison is mixed uniformly into the normal daily diet of the test animals. Since DDT is slow-acting, The way it is stored in the body tissues and the results of this accumulation can be studied over a long period of time. Tetraethylpyrophosphate, TEP for short, is a typical member of the other group of pesticides. These act rapidly, but either evaporate or break down into harmless compounds in a very short time. As this demonstration shows, a single drop of TEP in the eye can be fatal. Experiments with animals yield findings which can be applied to humans. But these experiments do not tell the whole story and only suggest how pesticides might affect man. So further studies are continued with human volunteers. These essential studies are based on laboratory findings and animal experiments which greatly reduce the element of risk. Men have been drinking measured amounts of diluted pesticide for several months in this long-range test. Each volunteer is given thorough clinical examinations at frequent intervals to determine any cumulative effects of the poison as it is stored up through repeated doses. Much of the knowledge gained in both laboratory and clinic can be translated into recommendations for the safe use of pesticides. These recommendations are then tested in the field. In this test of laboratory recommended clothing, to be worn when using highly poisonous insecticides, absorbent pads are attached to collect samples of pesticide spray. Cotton gloves, worn underneath protective rubber gloves, are used to collect samples of any poisonous material that would actually reach the skin. Laboratory-tested respirators are an essential part of the protective outfit when highly toxic pesticides are used. Here, one equipped with absorbent pads is used to measure the poison a worker would inhale if he neglected to wear his respirator. After use, the pads will be removed from the respirator and taken to the laboratory for examination. Field research of this type is the proving ground for laboratory conclusions, and in turn provides the basis for additional research in the development of safer techniques and equipment. At the conclusion of each test, underclothing, cotton gloves, and absorbent pads are carefully removed and turned over to the laboratory for examination. Chemical analysis of these materials indicates the extent of respiratory and dermal exposure, and the effectiveness of protective equipment can be determined. A quite different method is used to determine exposure to residential areas during extensive spray operations. Air samples trapped by special equipment and analyzed chemically measure pesticide concentrations at any given site. In companion studies, samples of fruit, vegetables, and other food products are collected and analyzed for poisonous residue, and complete meals are analyzed to determine the average daily consumption of pesticide contained in the food we eat. Additional contributions to the understanding of pesticides, impossible to obtain otherwise, are made by victims of severe accidental exposure. These patients enable research workers to observe the clinical effects and course of illness resulting from extreme poisoning. They also contribute greatly to the development of life-saving antidotes and treatment procedures. Knowledge obtained in the clinic, field, and laboratory becomes truly significant only when it can be put to practical use. Toward this end, various booklets and scientific papers are prepared by the research laboratories. These publications cover the entire range of pesticide research and are distributed to those who want and need this information. The most generally used publication, called Clinical Memoranda on Economic Poisons, is available through the government printing office. Consultation is a service often requested and supplied to state health and agriculture departments, county agents, physicians, and many others who need expert advice on pesticides. In addition, questions and requests for special information sent in by the general public are answered through personal correspondence. And although our knowledge of pesticides is still incomplete, research has given some of the answers, making economic poisons safer to use. Directions for the proper use of pesticides, based on research findings, are clearly stated on each container as required by federal law. The nature and amount of poisonous material must be given, as well as warnings against specific misuses. Dangers are pointed out, and if the formula is highly poisonous, antidotes are listed. When these instructions are followed, and pesticides are handled with common sense caution at all times, cases of poisoning are extremely rare. But accidents do occur, and it is important that the user of pesticides know what to do in any emergency. Even more important is the prevention of accidents. Many cases of accidental poisoning can be avoided if pesticides are stored where they are accessible only to those qualified to use them and kept under lock and key. Empty containers are always dangerous, especially to children and livestock, and should be destroyed as soon as they are emptied. During widespread applications, nearby homeowners must be notified, and fields and orchards cleared of all workers other than equipment operators. Harvesters and other workers can return after allowing enough time so that the particular poison used is no longer a health hazard. When label directions are followed, the residue on foods treated with economic poisons becomes harmless before harvesting and offers no threat to the ultimate consumer. Pesticide research is helping us to understand economic poisons. We're learning how to use them safely and without needless fear. But the work of the Public Health Service and other agencies engaged in similar research must go on. For there is still much to learn about pesticides now available, and each year will bring new compounds which must be studied carefully before they are released for general use. Because of this research, we are assured that the benefits from pesticides in greater comfort, less disease and economic loss, and bigger and better crops can continue without endangering public health.